What inspires you most at Sega?
What inspires me most at Sega is knowing that everybody at least interacted with Sega technology once today without even noticing.
We are the embedded experts because we have a solution for every embedded problem.
You can see us as a tool provider for other people that also make products. So if you build a house, you need a hammer, you need a drill. We are that kind of company, but for software engineers.
Debug and trace probes, production tools, embedded software and software tools. Our vision is to simplify everyday life for engineers and end users.
People using these products are developers all over the world working with embedded systems. Our market-leading J-Link debug probe is the one piece of hardware that you will find on every embedded developer's desk.
Sega technology is inside everything. Space research, medicine, robotics, motorsports. You can find Sega everywhere.
With our technology, I hope we make people's lives better or easier.
My main motivation is seeing all these projects come to life and change the world or improve the world. Sega is the professional home for so many different people.
Developers, makers, engineers.
What unites us all are three words.
It simply works.
So, before we begin, I've got a couple of questions for the room. So, first question is, who of you received at some point in their career, let's say, a formal programming training? Like in university or school or in an apprenticeship? Okay, that's almost as many as I expected. Who of you had a programming education in the university? Okay. Who of you is responsible for onboarding people that come from university and had programming training there? Okay. And who of you has ever taught at a university basic programming lessons? Okay. Today I would like to not go too much into technical details, as you have had plenty of quantum error correcting code lessons just a second ago. But I just want to tell you something about what I'm doing on most of my days, and I would like to get destructive feedback. I mean, there's always this assumption that you always need constructive feedback to make something better. But actually, I figured out that most of the programming training, especially in Germany, is basically just not good. So that was one of the reasons why I started teaching myself. And at the end of this talk, you may approach me and get a link to my learning platform, get credentials for that, and then you are free to rip it all apart and tell me where I've done something wrong. But first, let me tell you a little bit about my motivation, why this course looks like it looks. So, my name is Stephan Bökelmann. Some of you have already met me. I'm a research scientist here at the Ruhr University, and I'm in the study group of hadron physics. And I am working in the planning and building of deeply embedded systems. So probably doing pretty much the same that you're doing all day long. This is one of my embedded systems that I'm working on. It's not a tiny device, but it's rather large, actually. And I'm working especially on data acquisition equipment there. So mixed signal ASICs, FPGA readout of that, microcontrollers to, let's say, observe this process, and servers to collect the data. And this is basically the embedded system that I'm working on, which is nothing more than a fancy digital camera, but with a little bit higher throughput than regular digital cameras. Besides of that, I have some hobbies. So a couple of years ago, Odin and I started research and development as contract developers, and we do consulting for measuring and monitoring systems. So basically the same what I'm doing here at the university, just for companies. And yeah, there you can see some of our products. And well, a couple of years ago, I started as a lecturer at the University of Applied Sciences here in Bochum. And I'm teaching, well, it looks like 2 courses, but it's basically 1 course that consists of 2 semesters. The University of Applied Sciences is one of the oldest institutions in the Ruhr area. It was former mining school and then became a technical university at some point. So what do we expect from this talk? Well, I'll tell you a little bit about my approach of teaching, and you have to roast my approach of teaching after it. If I'm lucky, then I can motivate you a little bit to engage with me and my students, and maybe even contribute to what I'm teaching or how I'm teaching. And well, maybe you even contact me after the conference and help me tutoring my younglings, or have an exchange about how to tutor yours. And maybe you can also tell me about some teaching tools that I don't know about yet. Because I don't know whether you know or not, but university lecturers, especially when it comes to teaching, are not that good in exchanging in the exchange with one another. So it's really hard actually to get in contact with other lecturers that are doing basic programming training. I didn't think that when I started that, so I thought it would be way easier. Of course, I know there's this SG20 in the ISO committee working group for C++, but well, it's only C++ education. And as you may have remembered what I wrote on the slide, I'm not dealing in C or C++ training, but in introduction to programming and oriented programming. I'm using C. I'm using C++, but I'm using also C, I'm using Python, I'm working with shell scripting, we're scripting Vim, we're doing also a little bit of VHDL, just to get the students to have a basic understanding of what programming actually means. So when I started teaching, I thought first about what do I want to get from this, because well, nobody actually goes to lecture at a university to earn money, or if they do, they are probably not that bright. So the first thing I wanted when I started lecturing was to understand what separates good from average programmers, because in many cases it's actually not that easy when you're trying to hire somebody to find out in a short time who's actually good and who's average but putting in just more work than the others. Well, I'm not judging here what you need for your company or what you want to have, because sometimes you just want to have some average programmers that are just putting in the work, and sometimes you need just bright people that are lazy, Odin, and they can help you a lot with things, right? Because they typically find elegant ways to not do that much work. But yeah, I wanted to understand that, and I wanted to understand that by observing how different people learn how to program, and especially which basics and which fundamentals they have and which they need, and which you can query in sort of an exam. I also wanted to train myself by doing that, because as I mentioned before, Odin and I were trying to build measurement systems and monitoring systems. And of course, we're not doing that alone, but we're almost, we're a little bit less than 40 people at our company. And there are a bunch of, well, physicists, electrical engineers, and computer scientists that I have regularly, that I have to explain to our basic concepts on a regular basis. So, and also in onboarding, it can be sometimes quite hard to have somebody join the company that you build up for like 10 years, and you have a very abstract idea of what you are actually trying to do. And then you start trying to explain to them what you're actually doing, and they're just looking at you like you're a crazy person. So training how to explain concepts was one of the main reasons for me to start that, and also just to learn myself more about the fundamentals of programming, because there was this moment when I was almost finished with university, like end of 2013, and I was quite good in my C++ programming course. So I thought, well, I'm actually a really good programmer. But that was basically the Dunning-Kruger effect kicking in there, right? Then I went to meeting C++ with Odin for the first time, and I figured out that I'm actually pretty stupid. And that I didn't basically know anything about programming at all, right? Okay, then there's, then there is a thing that students actually expect from a course. I don't like to put that on the slide as the first thing, but that is actually the most accurate answer of what they expect. They want to pass the exam. They're not all of the people that are coming to university, especially when it's electrical engineers, who I'm teaching mostly, they are not all interested in programming. It's like maybe less than 60, no, less than 20% are actually interested in programming. And all of the others, they just want to pass the exam and consecutively get a degree and consecutively get a job. So what I was searching in this lecture series and what they are searching in the lecture series are actually two really, really different things that are really hard to put together at some point. And some of the students are trying to learn how to program, but as I said, it's typically less than 20%, and you can find out quite quickly who's that and who's not like that. And furthermore, there is something that's also there, what the university thinks I should teach in that lecture. And that is actually way easier to find out, because especially in Germany, well, there is a regulatory system of what a university has to teach. They come up with a module handbook, and this module handbook that gets audited by basically by a company that gets employed by the state, something like the TÜV. They check your module handbook and see whether they are aligned with the regulations that were put in place. And, well, so that's easy because they have to write it down. And, well, I don't know who wrote that down, but it's actually, it doesn't say much, but it says a couple of things that I want to point out here. After participation in the module event, students have acquired blah, 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 how to select and confidently apply all essential language constructs of a higher structured programming language. So who of you would say that they have achieved this goal yet? Yes. Pretty stupid to put that in there, right? But it's in there, so the university wants to teach me. To recognize the benefits of structured and standardized approaches also for other engineering tasks and transfer them accordingly. I don't even know what that means, to be quite honest. Yeah, I mean, yeah, there are some concepts of divide and conquer that where you can see parallels between different engineering disciplines, but to put that into this module handbook is really weird thing. And how should I put that into an exam, right? It's also, of course, after just one semester of programming without any prerequisites, basic network and graphics programming. Yes, think about that what you want. Essential concepts of object-oriented programming and their significance for the development of error-resistant and maintainable software. Like, yeah, okay, I don't think that most computer scientists with a master's degree actually understand that. And, of course, developing professional GUI applications independently also makes sense. Searching for possible pre-existent partial solutions, understanding their descriptions with the usual technical terminologies, also in English. And this has to be done in 130 hours. It just doesn't. And that is a translation from my actual module handbook, which I should teach accordingly to. I had a look in several other module handbooks from other universities, and they are basically even more obfuscated in some universities. But they all have like the same amount of hours. And if you think about it, 130 hours, it's just basically 3 weeks of work. Huh? So to go from 0 to what I just wrote down is just not possible. And that was one of the reasons why I decided to just, well, I hope nobody from the administration of the university sees this video, but where I decided to basically throw out a bunch. And, well, yeah, actually it looks a little bit more like this, right? But in the beginning I thought, okay, this makes sense. Other people taught that, and if they did it, if some professors before me did that, I will be able to do that too, right? And I just, well, when I started in 2018, I just took the former professor's manuscript and thought, well, everything should be in there. He did that for like 15 years. That must be good, right? So I tried teaching it. And in this 3-step process, I arrived at the next stage, failing miserably. So actually, in the first semester that I taught, I set up the exam actually before I started teaching in that semester. So I knew what I wanted them to prepare for. So there was basically nobody getting more than like 30% of the exam, and that was quite devastating for me. But I went through all of the material that the former professor had. I was pretty confident that the exam that I put out was pretty much in accordance with the module handbook. So I really had to think about what I was doing wrong. So I had a 4-step process of finding that out, starting with the most obvious thing, doubting myself and doubting whether I'm equipped to do teaching at all, because actually after such a devastating result, you feel pretty dumb. What I found out later was that ever so often professors then just tinker with the tinker with the standards and let like 70% of the people pass and throw out the 30% of the lower students. After that process of doubting myself, I came to step 2, doubting myself a little bit more. And then in step 3, I tried to figure out what other people were doing and what people learned from who I thought were good programmers and I could talk to about programming. So in 2019, which was after the first semester, Tabea and I flew to the standards committee meeting to Kona, and I tried to talk to as many of the senior programmers there as possible, which was quite easy. And even though I don't want to DDoS these standard meetings, I can only encourage you all to maybe participate in one of these if you're interested in talking to really bright programmers. So I took the chance to talk to people like Bjarne Strostrup and others, and I tried to figure out what they learned in university, what I wasn't teaching. And also I watched like all interviews and read all interviews with Brian Kernighan. And who of you knows who Brian Kernighan is? I hope. Okay, for everybody of you that doesn't know, you should probably check that out and listen to the interviews with him. He's the guy that wrote the original C programmer's handbook together with Dennis Ritchie. Yeah, so he was sort of, I don't know, he was a junior at Bell Labs at that time when Ken Thompson and Dennis Ritchie developed the Unix operating system and the C programming language, and he was basically writing all of that down. Also, if you've ever used grep or AWK, then you're using his code. Yeah, and then I revisited the exams and I did sort of a root cause analysis, what could have gone wrong there. And I came to, I had 3 observations. So the first one was that for most of my students, even after, oh, actually there's a bug there because it was only half a year of training. Programs were just mysterious things to them because, well, as I said, I took the old professor's manuscript. It's like, okay, install code blocks and type in that and press that button, compile and run, and something was happening. But they had like no idea of what a program actually is or what a program written in a higher language is and what the actual transformation between that was on a more conceptual level. It was, I typed that into this IDE, I pressed a button and it runs. Which I didn't ever think about that they could get to that conclusion, or that they wouldn't arrive at the same conclusions that I had, because when I started programming, I did that in the command line. But most of the students, they didn't use a command line. In fact, I had a student just 2 years ago that told me when I asked them to use the command line that he had never used a computer before, not even in school. They had used smartphones and they had used tablets. They didn't know what this black window with the white characters on it were. And what I also found out was that, yeah, of course, so students were also unable to run projects from GitHub to which I gave them the URL. They were not able to run that. They didn't even know what to do with the README or how to compile a program that they didn't write themselves. So they tried copying source code into code blocks and then said, yeah, it didn't work. Yeah, right. And when I looked at the exams, well, most of them were just copying the exact constructs that I was teaching in the lectures without what seem to me any understanding of what happened there. So they basically took the constructs, they read through them, and they just replicated them in the exam, which is obviously a bad idea because I changed the questions, right? So I came to 3 conclusions with that. The first of all is one thing that I didn't arrive myself at, but one of the teachers I had when I was, I don't know, 10th grade or something, and he never tried to teach us any complicated things, but he was only teaching us fundamentals of everything, because he said, well, if you know all of the fundamentals that I know, it is obvious that you should arrive at the same conclusions I have. And that is a thing that I didn't see in the manuscripts I got before from the professor. Before the professor I got that manuscript from, he was obviously very bright. He wrote a whole bunch of control system software in the 80s and 90s, and he put a whole bunch of examples in there that were, well, quite complicated. And even when I went over that manuscript, it took me quite a while to figure out those examples. So that was actually pretty stupid from me trying to teach them, because it took me time myself to find that out. Well, second thing, okay, most of these kids didn't grow up with any Amiga or Commodore or even DOS. So as I said, some of them just had a tablet. They've never used a real computer before. And third thing is, I wanted to no, it isn't. Well, yeah, magic. I wanted them to understand the actual challenge, tools to overcome them, rather than teaching them solutions directly. I mean, when you hand somebody an IDE, you give them a solution for a problem that they don't even yet understand. So what is it that I want from a programming training or a programming lecture? Do I want them to use an IDE? They don't learn anything from that. Because actually, if they can only use an IDE, they probably won't go into programming anyway. And if they go into programming, and they only can use an IDE, and they're not, and they can't move around in a command line, well, they have to learn it anyways. So teaching them an IDE is basically just a total waste of time. It just doesn't make any sense. So, yeah, that's a little bit small, but anyways, so I tried to restructure that whole course, and it actually took me like 4 years now until I'm at a stage where I can say with at least a little bit of confidence that I'm not totally screwing up anymore. Yeah. Actually, I don't even start with programming, but mostly with the history of machines that were built to compute results. Because most of the time, we just want to get some sort of answer from our machine. And this concept basically didn't change since the 1600s. Yeah? I mean, okay, we introduced electricity at some point, and we introduced Boolean logic at some point. But the idea of having a machine and asking a question to a machine and getting a result is basically the same concept. Then going over logic gates, because in the second semester they already also have digital electronics, or they should have thought a little bit about digital electronics. So explaining what a processor does in the first place, obviously not a modern x86 64 AMD EPIC whatsoever processor with all of the weird boxes, but just a simple 4-bit or 2-bit processor that has more than one operation, and explaining to them how they get from digital electronics, from logic gates, to a basic instruction set architecture. because that without that, they are not even able to understand what a compiler actually does, that it transforms a program or a list of instructions written in an abstract grammar, that a compiler transforms it to a list of instructions in a platform-specific grammar. They're not even capable of understanding that one processor isn't like the other, because they don't know about the actual instructions that go on. Before I go into programming with them, I just let them use the terminal and try to figure out how to work with SSH and how to work also with Git and Vim, and how we modify text files, because most of the times when we're programming, well, we're just doing text processing, right? Like, I mean, if you're not building a compiler yourself, well, even if you're building a compiler yourself, but most of the time it's just text processing. So being efficient in text processing, know how to, well, use AWK and grep and Vim, just takes away a whole bunch of cognitive overhead in the moment where you really need to focus on programming. So when you take the time to basically just work 2 weeks on how to move around in the command line, how to modify files, how to pipe from one process into another, how to redirect outputs, that makes text processing way easier. And after that, they don't have to think about text processing anymore. I really don't know what that is. I then focus mostly on memory and types before actually going into writing functions, so that we can understand that basically what a computer does is always take memory, do a transformation, write it back to memory. Okay, sometimes we have side effects, but most of the time it's take memory, transformation, write it back to memory. And there is a in the module handbook, there was something about correct programs. What is a correct program? Well, a correct program is one that only does like valid transformations on your memory, but what are valid states in memory and how can you define them? Because when you're just looking at the memory, well, first of all, every pattern that you can generate in your whole RAM is basically a valid state if you don't make any further assumptions to your program. So you have to basically restrict the possibility, the set of possible valid states, and you do that by types, right? I mean, types don't really add something to a programming language. They basically take something from you away because you're no longer able to do invalid transformations. After then, building basic functions and working with streams, I try to teach them make and GDB and also CMake, and you know what? It actually works. So I, especially with the last year, I did that. Most of them, like more than 50% of all the students, after 2 semesters, were able to write a CMake file from scratch for compiling first a precompiled library and linking them against an executable. Until I was able to do that, I think it took like 6 or 7 years until I just figured out what CMake was. And when I figured out what CMake was, I could way easier work with other people's projects, because before that, I was just not able to do that, right? And then in the last third, I'm working with sockets. Obviously, we're doing a little bit of distributed computing, basic distributed computing, like you set up a TCP server yourself, you send data there, you let it process, and you wait for an answer. So not to go into not to go into the real problems that occur with concurrent programming, but just to give them an idea of how distributed systems interact with one another, and also how you can interact with hardware, for example, and provide dynamic link libraries. And in the end, I typically do a little bit of graphics programming, either with CopperSpice or SFML to build physics simulations and see things going around on the screen, which is quite nice and gives them some sort of motivation at the end to really love programming because their balls are flying around. Okay, the tools that I use most regularly doing that, who of you knows Askinema? Okay, so you should check out Askinema. It's so cool because it's basically a video recorder for your shell, and you can copy from it afterwards. So when you're having any sort of process that you might want to document it in a shell script, but you could also provide people with the actual interactions that are happening, and they can copy out of it. That really helps, especially beginners, because they're seeing what happens in your shell and can copy things from that. As I said, I'm talking to them about instruction set architecture in the beginning, so we're using objdump a lot and really inspecting the object files, and also, of course, using Compiler Explorer. I tend not to use Compiler Explorer directly in the beginning because I don't want them to think it's magic, right? I mean, Compiler Explorer is really a nice tool, but I think there's a valuable lesson in knowing that you can do that on a machine without internet access yourself, right? Yes, of course, for like the first 7 months, they don't get any form of IDE. They just get their terminal and Vim and Git and GCC and Make and GDB and CMake. And after they've figured out all that, I typically provide them with some options to use an IDE, for example, like VS Code or something. And actually, some of them after that don't even want to use an IDE, which makes me a little bit proud that I showed them how easy it can be to manipulate text files in Vim. Vim is a great operating system. It lacks a good editor, though. Oh, that was Emacs, right? Yeah. Yeah, and of course I'm using Moodle, and I'm trying to integrate as much things as possible by using iframes, so they have all the data to each individual section in one place and can just scroll over it, and especially embedding Compiler Explorer iframes is quite handy for that. So yeah, what I end up doing most of the time is this. But I have a couple of future goals. So, as I said, right now I start feeling a little bit with what I have built as course material. So I hope that at next year's emBO I can present you with a GitHub repo that has all of the teaching material in it, and you can somehow, I don't know yet how, but you can clone it and run your own Moodle instance, because I've got some like tests and interactive programming exercises in that Moodle platform, but it is not that easy actually to extract that stuff from there. Well, you can archive it, and then you have a large archive, but it is not humanly readable, so you can't really put it into Git and version it. That's a little bit, yeah, I have to find a solution for that. I want to integrate more application talks in the lecture series, so if you are interested in maybe giving a talk for university students, it can be online as well, then please hit me up. And going to integrate that into my lecture series. Do more also with companies and search for companies that would like to cooperate. with their first-year employees, because from what I've heard, there's always, or in some cases, it can be quite hard for especially smaller and medium-sized companies to onboard their electrical engineers into programming. And I also want to find out what the requirements of companies actually are, because, well, right now I'm fulfilling my requirements, the needs of the students, and at least a little bit what the university wants from me. And also I would love to have more fun teaching. So since I said in the beginning, most of my students actually want a job at some point. Well, some of them just want to stay in university. But you can help me by maybe filling out this yet blank circle for me. If you'd like to help me with some of your hiring managers, or give an online presentation about your day-to-day work in my classes, meet me and tell me about your requirements, connect with me if you're also teaching, and when you write me an email, I will send you the credentials to my current course, and you are free to rip it apart and send me very destructive feedback so that I throw out everything that is unnecessary and only leave in the parts that are really mandatory for all people that want to start programming. Thank you very much.
Thank you so much for the overview. Are there any questions that we should discuss right now? Yeah.
First of all, thank you for the presentation. Yeah, full disclaimer: I do not teach, but you kind of asked for feedback.
Yes.
So I think this goes to me a bit in the direction where there's also a lot of discussion in schools, right? A lot of people say, well, I never use physics, or I never use biology in my future life. School should teach me about filing taxes or using Excel, because that's what companies use. And there are people on both sides arguing in favor of that, arguing against that. Personally, I would argue against that, saying that, well, it's country specific or company specific, like Excel, Microsoft company. And I see similarities with how you structured your course. So you do ISA introduction, so you show them how a processor works, you show them how functions work and types. But from what it looks to me, you put the main focus on tools like make, CMake, GDB, how to use them, how to use a shell. Why do you put the focus more on that? So wouldn't it help the students more to understand, or to go deeper into the understanding of how a function works, how an architecture works, how the compiler does its transformation, instead of specific tools that are mostly used right now, granted, but in 10 years might not be used anymore. So who knows what in 10 years if someone uses CMake or Make or GDB? Probably yes, but it's tool specific. That's what I mean, and it's very focused on that tool.
Yeah, you're absolutely correct. I mean, there is always this discussion about theoretical background and applicational knowledge, and I don't want it to be a theoretical course. I mean, if they're not studying electrical engineering to get a degree in theoretical computer science, so that's one of the reasons. But I think that there are some parts that are necessary, and those are the parts that I'm trying to highlight, and I'm trying to fill the rest of the time with applicable tools that are, yes, that might be deprecated at some point, but I guess it is very likely that also in 10 or 20 years, there will still be make files out there, and you will still need a text processor, and you will still have to connect to a non-local machine using some form of wired protocol to have a teletype. Those are things that are mostly invariant to also the different generations of programming that have been there. So, for example, if you when you look at, let's say, the first let's say modern computer, a PDP-11, yeah, the basic interfacing of output devices and input devices, well, it somewhat relies on the same concepts that we're using with terminal emulators still today. So even you are absolutely correct about this conundrum, and that's why I hope to get feedback from you all. Yeah, thank you.
We got another question.
Yeah, I just want to follow up on what Rainer said. So I have a different, it's a bit silent now, I don't know. Okay.
No, it's...
So I have a different approach on that. So what I see in the working actually outside, not from, I studied, so before I finished my study, I didn't know how economy side works of programming. Now I do. So I would argue that the best approach is to not do deep dives in the bachelor's degree and do this in the master's degree, because there are a couple of advantages from that. Because in the master's degree, you can, the students themselves, they can choose what they want to deep dive on. And the bachelor's degree instead should give them the adaptability, to make them achieve adaptability to be able to work on different things. So, and this adaptability can only be truly achieved by a broad approach. So if we start to focus on details, then this broad approach will be harder for students, because they will be filled with stuff trying to understand that. And as you said, time is a resource. And yeah, I would say a broad approach is for the bachelor's degree better, to give them adaptability.
I agree.
With having a look at the time, and I guess that probably ends in a discussion, which is pretty cool, but there's also coffee and cake waiting. So if you want to give like a short statement, that go for it. And otherwise we'll go for coffee and keep it offline.
Just a quick response is, I agree 100%. And I believe that my approach is more broad and less specific than teaching somebody to use an IDE. Yeah, thanks.